So yesterday we talked about 5 theorems, the same side interior angle theorem, the alternate exterior angle theorem. Today we're going to take all those theorems and shake them up. Today we're going to talk about the converse of all of those theorems. So you told me already, converse means reverse. It means change, switch the hypothesis and the conclusion. So if P then Q becomes if Q then P. So that's what a converse is, and today we're talking about the converse of our theorems. So, if our theorem yesterday was if line K is parallel to line M, then the corresponding angles are congruent. If parallel, then corresponding angles are congruent. The converse would be if, you guys fill it in your head, if corresponding angles are congruent, then K is parallel to M. So the difference of what we're doing today is we are not going to assume our lines are parallel. The jury's out. I don't know, these lines might be parallel, they might not be parallel. But we're going to decide if they're parallel based off of the angle relationships we learned about. For example, if I told you this angle was 112 and this angle was 113, what would you say? Are these lines parallel or not? You would say no. You would say K is not parallel to M because the corresponding angle, or no, the alternate exterior angle theorem isn't working, because 112 is not equal to 113. So we're just flipping it today. It's like we're working backwards. We're not telling you the missing angle. We already have the angles, and we're trying to decide if the lines are parallel or not. So we're working backwards today. So go ahead and you can put these examples in your notes. We're going to decide if K is parallel to M using the evidence given to us. Don't type your answers yet. So in the green picture, is K parallel to M? Go! It was supposed to be easy, but we have mixed results. Okay, let's find out. All right, so let's start by naming these two angles. These are same side interior angles. The theorem says that if same side interior angles are supplementary, then the lines are congruent. So are the same side interior angles doing what they're supposed to? Are they supplementary? Did you check the math? 72 plus 98? No! That does not equal 180. So is K parallel to M? No! Because the same side interior angles were not supplementary. So for the lines to be parallel, the theorems have to be true. The theorems have to hold true. That theorem wasn't holding true. The theorem said they were supposed to be supplementary. They're not doing what they're supposed to. They get a punishment. Their lines are not parallel. Anyways. All right, what about the gold? Yes, of course. This one's going to be yes because the other one was no, right? Yes, and the reason why is because the same side interior angles are supplementary. That is why K is parallel to M. So first you'd say, what's the vocab word? Same side interior. Okay. Then you say, which team is it on? Team congruent or team supplementary? You're like, oh, team supplementary. Then you look at the picture and you're like, oh, these guys, these angles are either doing what they're supposed to or they're not. They're either adding up to 180 or they're not. And in the green picture, they didn't add up to 180, and in the yellow picture, they did. Yes or no question. Trying to connect it to the real world here, people. Try my best. A pipeline intersects 2 lanes of a highway, which totally happens. There's pipelines all underneath those highways. You can kind of check 290, look at the construction, and see what's underneath. What must the value of X be to ensure the 2 lanes are parallel? It's your job to make sure that those lanes are parallel. You're the quality control person. You measure those angles. What do you need to come up with? What should the relationship be? Anyways, go ahead and solve for X and type it. So step 1, identify the vocab word. You have to know your vocab so well by tomorrow. These two angles are, for the third time in a row, they're same side interior angles. We know same side interior angles are supposed to be supplementary. So the theorem we're using, because it's converse day, if these two angles are supplementary, then our lanes will be parallel. So we need to make them supplementary because we don't want to get fired from our job because they weren't parallel and it caused traffic accidents, right? So we want these to be supplementary, which means they add to equal 180. You do not set them equal to each other. That is not what supplementary means. X is 28. We're going to move on because we've got better stuff to do. Okay, this one's kind of fun. So I'm going to give you some information. This is like your clue. And you tell me if that is or is not enough information to say that A is parallel to B. Let's do the first one together. Angle 2 is congruent to angle 6. So that is given information. You don't say true or false. No, that's given to you. They are congruent. What you're trying to decide is if that forces A to be parallel to B or not. So you write the vocab word down. 2 and 6, alternate interior angles. What are they supposed to be doing? What team are they on? They're team congruent. The alternate interior angles are congruent. They're doing what they're supposed to. So A is parallel to B. Confirmed. Is parallel. Those are. We're not assuming they're parallel. We know they're parallel. Okay, let's do the next one together too. 8 is congruent to 5. Okay, 8 and 5, vocab word. Same side exterior angles. They're supposed to be supplementary. Oh no, they're not doing what they're supposed to do. So A would not be parallel to B. You see that symbol parallel with a slash through it? That's an actual accepted symbol. A is not parallel to B because they're not doing what they're supposed to. They're not fitting. If you don't fit the hypothesis of a theorem, you definitely can't fit the conclusion. The conclusion can't be assumed if the hypothesis doesn't even hold. Okay? Next one. Measure of angle 7 plus the measure of angle 3 equals 180. Oh no. Those are alternate interior angles. They're supposed to be congruent, but it's saying that they're supplementary. I'm not saying that that's wrong. They could be supplementary, but it doesn't force parallel lines. So they are supplementary, but that's not what we wanted to happen. That's the wrong hypothesis. So A is not parallel to B. Let's try it now with 16 angles instead of 8, okay? All right. This one doesn't say determine if the lines are parallel. This says name the lines that are parallel because there's multiple choices here. It's not as bad as it looks. Come on, we can do this. Let's reveal the first piece of evidence. Think of this as a piece of evidence being submitted, and it's your job to be like, oh yeah, they're parallel, or no, that's not good enough. That doesn't fit. Here we go. Angle 1 and angle 13 add up to 180. How do you always begin? You say the vocab word. What's the vocab word? You already did it. Good job. Same side exterior angles. They're supposed to be supplementary. They're doing what they're supposed to. Therefore, we have parallel lines. Which lines are parallel? Go ahead and type it. Which lines are parallel? With 1 and 13. Good. So the answer is name the lines. The answer is D is parallel to C. We don't need, look, line B is not even involved. You don't use line B at all. So the only lines left that would be parallel is D and C because A is the transversal. All right. Next one, totally new problem. 6, the measure of angle 6 plus the measure of angle 7 equals 180. Vocab word. Good. Same side interior angles. They're team supplementary. They're doing what they're supposed to. So which lines are parallel? Which lines? Good. A is parallel to B. Keep going. Angle 3. Oh no, I lost my eraser. 3 and 16. The measure of angle 3 equals the measure of angle 16. Alternate. Look how much vocab we're practicing today. I'm practically reviewing you for your vocab quiz tomorrow. Alternate exterior angles, they're supposed to be congruent. Their measures are equal, which means the angles are congruent. That's the same thing. So, good job. D is parallel to C again. Alrighty, 2 more on this page. 14 and 16 are supplementary. What do you think? Good. Vocab word, corresponding angles. Good. Corresponding angles are supposed to be congruent. Oh no, this doesn't fit the hypothesis of the theorem. This doesn't fit. So which lines are parallel? What do I write? Name the lines that are parallel. So you write none. There are no perpendicular. There are no lines that are parallel. They're not perpendicular because you're assuming they're both congruent and supplementary. But all we know is that they're supplementary. So for all we know, this could be 70 degrees and this could be 110. And then there wouldn't be any perpendicularity. Is that a word? If it is a word, I want to use it all the time. Perpendicularity. Okay, last one on this page. The measure of angle 9 equals the measure of angle 14. What do you think? No, this is not a true or false question. It says name the lines that are parallel. Good. For those of you who said none. This one's a little bit weird. Yay! This one's a little bit weird. These are vertical angles. The vertical angle theorem says they're supposed to be congruent, and they are congruent. So what's the deal? Why did we put none? Yeah, that's what I'm asking you. The words from last unit, vertical angle theorem, linear pair theorem, those cannot prove parallel lines because all you need for vertical angles are 2 lines crossing, and all you need for linear pair is 2 adjacent angles. Those vertical angles and linear pairs cannot make parallel lines. So even though that last one is telling the truth, it still does not, the conclusion is still not parallel. Is the conclusion to the vertical angle theorem, then the lines are parallel? No. So we still put none, okay? Determine if AC is parallel to DF. So if I were the student and this were like a quiz or something going in the grade book, I would highlight the lines in question. Okay, these are the lines in question. Is AC parallel to DF? We don't know yet. We don't assume it. Okay, so we're going to look at all of our information and mark it on our picture. EDF is 28. EDA is 100. And CAD is 53. Dun, dun, dun. So what do you think? All right, let's go over it. Let me just write this. Well, okay. Step 1, name the type of angles. What type of angles are we given to work with? This angle and this whole angle. What are those? Same side interior angles. Could we have used other ones? Sure, but those were given to us, so we're not going to do extra work if we don't have to. Same side interior angles are supposed to be supplementary. Did you add them up? Did you add them up? Are those two angles supplementary? So you've got 53 and you've got 128. Are those supplementary? I can tell right away that they're not, because 8 plus 3 is not, doesn't end in a 0. I can tell right away. They are not supplementary. So the answer is no, and the theorem is the same side interior angle, and you can put theorem afterward or whatever you want. The reason is the same side interior angle theorem. That's the correct reason why. Okay? So the answer is no, because the angles weren't doing what they're supposed to. They were supposed to be supplementary, and they just weren't by 1 degree, but that matters. All right, very last one, promise this time. Name the lines that are parallel. I'll give you a minute. Okay, we need to name the lines that are parallel. So, did you find any same side interior angles that are supplementary? Did you find some? Name the degrees. Oh, these two are. There's a pair. So which lines and which transversal make up those angles? Oh, the lines are AC and BD. Do you see that? AB is the transversal. AB is not the parallel lines. The other set is 95 and 85. Here's the transversal. Here's the parallel lines. Once again, it's AC and BD. I hope you're having a light bulb moment. When you answered it, that AB is parallel to CD, then you're telling me that these two angles are supplementary, and they're not. So just be careful and highlight things and bold things so you can tell which is which. Yep.